thing about the test is that you can use your study guide on it, which means I'm not taking it in the study guide as a grade. So if DJ doesn't do a study guide, I'm not going to know. But what's the point? Because he wants it to help him on the test. Okay, so when we get done talking about the notes, I'm actually going to pull up and show you the test, and we'll talk about how many problems of this and how many problems of that. I just don't want to do that in recording. Okay, so there are some rules of exponent problems on the test tomorrow. So that's why we're skipping 1, 2, and 3 today and going straight to 4, 5, and 6. So on number 4, what am I supposed to do? Yes, ma'am. And what did you do with it then? Okay, and you can have a point. Abby Grace does not have to be my twin in life, which is fine. This is how she did it, and we're going to end up getting the same answer. But I actually did not start off doing it immediately the way she did it. I fixed one other step first. Yes, dear. I did. I fixed the negative exponent first. And then I raised everybody to the third. But me and Abby Grace are going to end up with the same answer. 5 to the third is 125. 6 times 3 is 18. 9 times 3 is 27. So we both got the same answer. We just did it in a different order. I don't know if I gave you a point or not, Landon. I should have. So when we're raising a power, we have to multiply our exponents. So that's if you forgot to multiply the exponents, you've got some studying you need to do tonight. On number 5, I would have thought because there's a division symbol, we were going to have to do what to the exponents, is what I thought. I didn't read the problem first. I thought we were going to have to subtract, so we get another point. However, I'm incorrect. Why do we not actually have to subtract on this problem? Yes, both the C's are in the numerator, so I'm actually going to do C to the third, C to the sixth, and get C to the ninth. Both the D's are in the denominator, D to the 10th, D to the 1, I end up getting D to the 11th. So I don't actually have to subtract anybody. They tricked me. I'm missing a number. Yeah, it's negative 7. Negative 21 divided by 3 is negative 7. So number 5, well, they kind of sort of tricked us, not really. It wasn't hard. I just thought I was going to have to subtract, and I didn't. If you missed number 6, it makes me sad. There was someone in first period who said the wrong answer out loud. 3 gets the point. If you thought it was cute in the night, don't forget about that understood 1. 3 plus 6 plus 1 is 10. Okay, are there any questions about these math workshop problems? The exponent ones should be easy. If they're not, you need to look back over it or ask me a question or something. There are 8 of these on the test tomorrow. There are 20 questions total. 8 of the 20 are on this. Okay, how about your notes packet for me? I want to talk about your study guide for a second. Or a few minutes, actually. Long. I posted the key to your study guide yesterday afternoon. And I want to talk about that. And then I want to talk about specifically the back 3. So I posted the key. You should already be working this out. If not, you've got a lot to do tonight because DJ would like for this to be helpful for him, so he'd like to have the answers. The first 5 questions are rules of exponents. No big deal. Should be easy. Like I've already said, the first 8 questions on the test, also rules of exponents. Should be easy. 6 through 11, we talked about those the other day, and we actually worked number 7 together. 6 through 11, while they make the test, they're not this complicated. There are problems on the test that want you to, let's say, add and combine like terms. There are problems on the test that want you to distribute, like on number 10. But there aren't any problems that want you to add, distribute, and still name degree, leading coefficient, and number of terms. The degree, leading coefficient is a completely separate question. So thankfully, it's not this much required from one question. All you'll have to do It's like add the like terms, get that answer, and then you're done. You won't have to state the degree, the leading coefficient, and number of terms all in the same problem. That's a bit much. So 7 through 11 should be pretty easy. Then we get to 12 through 19. Just like the directions here where we've crossed out the word long and synthetic, on the test it just says divide. It doesn't say which method you have to use. If DJ was being super smart on a problem like number 12, maybe he would do both and make sure he gets the same answer both times. But, you know, that's a lot of work. I'm not going to lie, the division problems take some time. I know, it takes me a few minutes as well, especially when I do long division. Okay, and then if you did not understand 20 through 23, I'm a little concerned. It should be really easy to state the degree. If you're having trouble with degree, you're overthinking your life. So the only ones I literally want to go over today are the graphing ones. It's the very back page. I want to do those instead of graphing notes today. So I do not make the tests. I'm thankful for that. But I do give them. So I assumed, since the graphing was inside our notes packet, that we were going to have to graph on the test tomorrow. While we do not have to graph on tomorrow's test, we are going to eventually have to graph. So it's smart for us to go ahead and discuss it. And that's what we're going to be discussing Wednesday, Thursday, and Friday. Okay, but there are things you have to do in order to graph, in order to go from this to a graph that is going to be on the test tomorrow. For instance, to go from this to our graph, we might need to list off the zeros. That is something that would be on our test tomorrow. So what are our zeros for this problem? And, okay, Landon was the first one saying them all. Let's give him the point. -2, 1, and 4. Now, again, it seems smart of us to go ahead and put those points on our graph. The zeros, the whole reason we find the zeros is because that tells us where our graph crosses the x-axis. And I bet Brady's going to answer my next question, and he's not even meaning to. Go ahead, Brady. Yeah, so what's the vocab term I want you to use? Yeah, so 2 and 3 get a point. Another thing we might want to notice is the multiplicity of the zeros. The 4, because of that 2 there, the 4 has a multiplicity of 2. And all that really helps us know is that something special is going to happen at 4. At -2, at 1, it might just cross through. At 4, something special is going to happen. So that's why we note the multiplicity, because that lets us know where the special points are on the graph. They're even more special than just a 0. They're like the coolest of the zeros. Another thing we have to list on the test tomorrow that you've practiced before is the degree and the leading coefficient. What is the degree of this polynomial? Yes, it's 4. Don't forget, I'm adding them all up. So 2, 3, 4, the degree is 4. Now later this week, when we really get on graphing, we'll talk about what a 4, what are something to the 4th degree, what its graph normally looks like. The way you know something squared normally looks like the parabola. But for today, and to the test, and just future notice anyway, the higher the degree, the more loops or whatever it's going to have. That's why we look at the degree. It lets us know, anticipate how many times we might cross the x-axis. Okay, and then the leading coefficient, I don't need an actual number today, or for this problem. I'm going to assume it's 1, but really what I want to know is it a positive or a negative number? And since it's a plus sign out here, I'm going to assume it's a positive. And all that helps us know is stuff about end behavior, like we start off happy, do we start off sad, that kind of thing. again. So, yes, you have to be able to list these things tomorrow. In fact, you have to actually give the number for the leading coefficient. No, you don't have to make the graph. But the whole point of making this list is to help us make the graph. So why not be brave and go ahead and make the graph? Yeah, well, I think there are special problems on zeros and multiplicity and then separate problems on degree and leading coefficient. But the whole point of making you do any of those things is how do you graph? Bam. Okay, so the degree is the highest exponent. This is the best question I've had yet. The degree is the highest exponent, and it's really easy to spot on number 2, for instance, because you're like, oh, highest exponent, that's a 3. But on number 1, since it's got all those little parentheses, I seriously just add them up. So that one's an understood 1, an understood 1, that one's a 2. So I said 2, 3, 4. The highest it can be is 4. I'm just adding. So I really, for degree, it's way easier when it's in that form. This form, I have to actually think about it. Okay, so I've got my list. I've already marked my zeros. I know my degree. I know because my leading coefficient is positive, my graph is probably starting off happy. I know it's got to loop through these things. Again, I'm just making an educated guess. And then since we discussed 4 is special, 4 has a multiplicity of 2, it has to do something a little extra special at 4. It's not just going to cross through 4 the way it crossed through 2. It's going to bounce there, yes. But again, you don't actually have to stretch the graph tomorrow. You do in the future. But you do have to make this list. And what's the point of making this list if we can't apply it to a graph? Okay, are there any questions on number 1? Why is number 1 different from number 2? The parentheses, and number 1 is a certain kind of form. If you look through your notes and you find it, I'll give you the point if you tell me. It's something form. Number 2 is standard. But I need to know what number 1 is. Something form. And you get the point. Factors form, meaning it already shows us the zeros. So number 2 is annoying because we don't know the zeros. We're going to have to actually do a little work in order to get to those zeros, which is why we've been practicing and practicing how to factor. Okay, so while I'm going to have to work to get the zeros, I don't have to work for the degree or the leading coefficient. What is the degree on number 2? And what's the leading coefficient? And we got to be specific. It's -1. Again, I'm mostly focusing on that negative sign today. But yes, on the test tomorrow, if there's a number, you need to give it. Okay, so sadly enough, we can do degree and leading coefficient, but we can't actually list the zeros until we factor. Is there something we could pull out to help us factor? More specific. Let's pull out a negative x, and you can have the point. Then we'd be left with x squared plus 7x plus 10. So let's pull out a negative x. If we pull out a negative x, is there some way to factor x squared plus 7x plus 10 to have two pretty binomials? X plus what and x plus what? 5 and 2, 3 gets the point. 2 times 5 is 10, 2 plus 5 is 7, that's perfect. So the reason we did all this is because now we can finally list off those zeros. Where are my zeros? Why am I mad? Still mad. Thank you. The first class period missed well. Brady fixed it. The first class period did not get it instantly. Yes, the -2 and the -5, but don't forget, what we did is we set each of these equal to 0. So yes, x plus 2 equal to 0, you do get x equals -2. But negative x equals 0, you end up getting x equals 0, not x equals 1, not x, like, you can't forget about it. You end up getting x equals 0. So 0 is one of our zeros. Yes, ma'am. Can you please send Corbin Chandler to the incident window for a minute? Yes, ma'am. So if Abby Grace forgot 0, she's only going to put a dot at -2 and -5, and everything's going to be off. Okay, in number 1, we listed off degree, leading coefficient, and zeros, and we also listed multiplicity. Do we have to deal with multiplicity in this problem? Why? Yeah, it's not like it's x plus 5 to the third. Then -5 would have a multiplicity of 3. There's nothing like that. So there's none with a multiplicity higher than 1. So I'm not even going to list it. And I'm just thinking in my head, that means we're just crossing through each of these points. Nothing special is going to happen. Okay. That's what would be on the test tomorrow. Can you make that list? But I can't help it because, again, the list is to help us graph. So what we're going to talk about later this week. Yes. Yes. Literally because of the exponent. Okay, so on number 2, I know you're not genius, and you're just supposed to know this. Okay. But you can get your graphing calculator and confirm it and everything. I just know, and we're going to spend time on this later this week, that a cubic ends up looking like a snake. I just know that. Again, Miss Compton's done math for years. Eventually you get used to things. A cubic always ends up looking like this snake. And so since it's a negative in front, since that leading coefficient is a -1, I know in our case it's going to be a backward snake. So instead of starting down, he starts up. It's going to be a backward snake. Again, do I expect Abby Grace to know that today? No. Is that something we're going to talk about later this week? Yes. I just have to throw it out there now because math is so cool. So I know I'm going to start up here, somehow bounce through, come back and cross here, and come back down. Since I didn't have any special multiplicities, everybody just crossed through once. And again, if you graphed it in your calculator, it would confirm that it was this kind of a down one. But while it's cool if you understood this graphing bit, again, that's later this week's problem, not tomorrow's test problem. Yes, dear. It's going to end up, we're going to talk about this later this week, but it's got to do with it being an even degree or an odd degree. Even ones are going to have the same end behavior. Notice how they're both pointing up. Odd ones have opposite end behavior. Notice how one's up and one's down. So it just depends on is it going to be even or odd as to that end behavior. Okay, number 3 about made me want to cry yesterday. I'm not going to lie to you. I didn't really feel like doing math, and number 3 looked hard because I was overthinking my life. I got the degree. I got the leading coefficient. The degree is what? Oh, that took too long. The degree is 2. The leading coefficient is +1. Yes. Okay, cool. And then I got mad because I need to factor this so I can figure out my zeros. And this looked really hard to factor. I'm overthinking my life. What do I need to do? Grouping because there are 4 terms. 2 gets the point. Grouping. There are 4 terms. I can do grouping. What can I pull out of that first group? 5 get the point. If I pull out an x, I'm left with an x plus 7. What can I pull out of that second group? Yeah, you can pull out a -1. I'm going to write it. Do you have to write the 1? Absolutely not. Okay, so that means we're doing x minus 1 and x plus 7. And she's already stolen the words right out of my mouth, which is how her group has got so many stinking points. Take another point. Okay, the reason we did all that is so we could figure out the zeros. So our zeros are at 1 and -7. So 1, -7. So we figured out the degree. We figured out the leading coefficient. We actually had to work a bit to figure out the zeros. Do I have it? Do I need to worry any about multiplicity? No, there's no multiplicity on this one. So our graph is either going to look like, it's got to go through those 2 points. It's either going to be a happy face or a sad face because it's a positive one. Yes. Oh, I'm trying to give 6 the point and it was you. Because it's a positive one, it's going to be a happy face. Do not tell them the answer to this one because I asked it like your period too. That graph is called something. What's its name? Like we named it. We're about to start naming other people too, so my gosh, we got to at least recall its name. What is that called? 2 get another point. Lord. When she's hot, she's hot. So hopefully yours looks a little prettier than mine, but we get a parabola. I have an answer. Was it x minus 1 squared? Is it x minus 1 squared? No. So that's why, no, it doesn't have multiplicity too. Plus, if you're ever dealing with parabolas, well, that's too deep. I'll tell you that in a second. Well, I can't say it out loud to the whole mass. That'll confuse the world. Okay, but again, the graphing is great, and I'm glad we're catching on, but the whole point is, hey, the zeros, the degree, the leading coefficient, all this work, we've had to do factoring, it's leading somewhere, but it's not on the test tomorrow. Are there any questions about this? Then let me show you the test.